Question from October, November 21, 9709, variant 32. The equation of the curve is, so you're given a implicit equation and question is show that dy by dx equals to, this is the result which we want to prove. 2y e power x minus y square whole divided by 2y minus e power x. So write the implicit equation y e power 2x minus y square e power x is equal to 2. Next, write differentiate with respect to x. So keep in mind that the derivative of y with respect to x is dy by dx. Uh, Here is the product rule. Here is the product rule. Y and e power 2x, y square e power x. So the product rule is, if you're given dy by dx of uv, it is uv dash plus vu dash. This is called the product rule. This is the product rule of differentiation. Also, for this implicit differentiation, you must keep in mind that derivative of y with respect to x is dy by dx. Now, coming to this solution, we have the product rule. For the product rule, you may take this as u, the other as v. So we have two terms. The first term is the product, second is again the product. So here, y as it is, and the derivative of e power 2x is e power 2x into the derivative of power, which is 2x, the derivative of 2x is 2, plus e power 2x as it is, this v, and then derivative of y is dy over dx. This is a differentiation of the first term. Minus bracket. Again, there is a product uv. We keep first function as it is, y square as it is. The derivative of e power x is e power x plus, now it is vu dash. E power x now as it is, derivative of y square. So this is the power rule. Derivative of y square is 2y raised to the power 1, and the base is y. Its derivative is dy by dx, should be clearly written here, is equal to 2. The derivative of 2 is 0 because constant. 2 y e raised to the power 2x, e raised to power 2x dy over dx minus y square e raised to the power x, minus into plus is minus, simplify 2y e raised to the power x dy over dx equals to 0. We're looking for the expression for dy by dx. Now, keeping, so you can write 2y e raised to the power 2x minus y square e raised to the power x is equal to 2 y e to power x dy by dx minus shift it on the right side, e to power 2x dy by dx. On the left hand side, y is common. So 2e raised to the power 2x minus y e raised to the power x minus y e raised to the power x, or you just, instead of taking common, just keep this, only take e power x common. So you'll have to look at the result. What is the requirement? So take e power x common here, then inside the bracket there is 2y, as it is e power 2x and e power x is common, e power x minus y square and ex is common, is equal to, from here e power x is common, also dy over dx is common. So e power x is common and dy by dx is common. So if we have the common dy by dx, which I'm writing outside the bracket, and e power x is also common, so what is left inside? So it is 2y minus e raised to the power, this is 2y into, as it is e power 2x and e power x is common, simply e raised to the power x. Next. Next, you can cancel ex on both sides, and finally we have 2 e power x, 2y e to power x minus y square divide e power x, 2y minus e to power x equals to dy by dx, and finally dy, this implies dy by dx is equal to 2y e raised to the power x minus y square over 2y minus e to power x. Match the result. Denominator is 2y minus e to power x, 2y minus e raised to the power x. Numerator is 2y e power x minus y square, and yes, this is the required result. This is dy by dx. So here, product rule, and again the product rule, and this is the product rule. And by applying the product rule, we differentiate y, and yes, the derivative of y with respect to x is dy by dx. This is the important step. So as it is y square, the derivative of y square is 2y raised to the power. So this is basically the power rule. 2y, subtract 1 from the power, it is 1, and base is y, its derivative is dy by dx should be multiplied here. And in this case, it was simply y. So the derivative of y is dy by dx. So product rule in the first term, product rule in the second term. And so we have the answer to this question, this part A. So using this algebra, you can reach the answer. Second part is find the exact coordinates of the points on the curve where the tangent is parallel to x-axis. So if we have x and y-axis, and if the tangent is parallel to y-axis, say this is the tangent for some case. So any line which is parallel to y-axis, the gradient for that is undefined. Or you can say the gradient is 1 over 0. So as you're given dy by dx is equal to, this is the expression given, 2y e power x, 2y e raised to the power x minus y square divided by 2y minus ex. So we know that dy by dx gives you the gradient of the curve or gradient of the tangent. This is the expression for this is the gradient of tangent. Gradient of the tangent or the gradient of the curve at a point. So this is the expression, this is the formula for so this is the gradient function. Now, as given that tangent is parallel to y-axis, so gradient of tangent is undefined, means infinity. That is dy by dx is undefined. So this is possible if the denominator of dy by dx is equal to 0. So for this part, you put dy minus e to power x is equals to 0. This is the important point for this part. Now, the question is find the exact coordinates on point on the curve, and yes, this is the curve. This is the curve. Y e power 2x, this whole thing is the curve. So here I can, this is one equation, and the curve equation is y e power 2x minus y square e power x equals to 2. This is the curve, and this is the equation which we are obtaining by equating the denominator to 0. Why denominator equals to 0? Because the tangent is parallel to y-axis. The gradient is undefined. So if the gradient is undefined, means 1 over the denominator must be 0. So this is the important point here. So solving 1 and 2. Solving 1 and 2. So how to solve these two equations? From 1, I can write e power x is equal to 2y. If e power x is 2y, then e power 2x would be y square. So using, because scaling both sides is 4y square. Using in 2. 2 is here. Y is y, e power 2x is 4y square minus y square, this y square, and e power x is 2y is equal to 2. So 4y cube minus 2y cube is equals to 2. 2y cube is equals to 2. So y is equals to 1. Y cube equals to 1, and this implies y equals to 1. So this is the y coordinate of that point. And if you have the y coordinate, you can use this y in the equation, say here. So using 1 or in, so put in 1. They put this value in 1. 2y minus ex, 2y minus ex is equals to 0. 2 into 1 minus ex equals to 0. So ex is equals to 2, and log, using the log on both sides, the definition of the log. So if e power x equals to 2, then x is equals to natural log of 2. So this is the x coordinates. So question was, find the exact coordinates of the point on the curve where the tangent is parallel to y-axis. Hence, the exact coordinates are here. Natural log of y, comma 1. These are the exact coordinates of the point on the curve where the tangent is parallel to y-axis. So this is just for the idea. Say this is the tangent. Thank you.